Well, hi everyone. Several of you reached out to me about the Ukrainian attack on the Kerch Bridge, Crimea Bridge, that Russia built between 2014 and 2018. And I want to address the foundation engineering aspects of this attack and give you my take on what damage could have occurred, how could they assess the damage, what were the design and construction implications for this type of foundation for this bridge, and just give you a complete overview. So we have this footage from the security services of Ukraine. I don't know if they've hacked into the CCTV footage from the security cameras at the bridge, but you can see this explosion occurred right at a bridge pier location. Now there's been a lot of speculation online that whether this was a explosive delivered by an unmanned submarine or boat. Reading between the lines, I think this nearly 2,000 pounds of explosives may have been placed with special forces because they reference that they mined the bridge. So a little unclear on those details yet, but clearly a massive explosion. And we see headlines like this. This happened on June 3rd, 2025. I'm recording this video on June 4th. Ukraine hits bridge linking Crimea to Russia with underwater explosives. Well, that's certainly the case. And this follows on the heels a day or two after this bold and very innovative attack using staged drones to take out a lot of Russian bomber aircraft. So let's go through this. We've got this area right next to the pier. We've got this explosion, and apparently it did a lot of damage to the bridge deck overhead as well. So I'm just going to read this statement that SBU posted on social media. The SBU conducted a new unique special operation and struck the Crimea Bridge for the third time, this time underwater. The operation lasted several months. SBU agents mined the supports of this illegal facility, and today, without any civilian casualties, at 4:44 a.m., the first explosive device was activated. And I understand there was a second device that was detonated later that day. The underwater supports of the piers were severely damaged at the bottom level, using 1,100 kilograms or about 2,425 pounds of explosives in TNT equivalent contributed to this, SBU further claimed. In fact, the bridge is in a state of emergency. Well, according to reports, the bridge was immediately closed, and that closure lasted several hours. And then Russia touted that they were able to reopen the bridge. But I've got questions about what that reopening really entails, and I'll go over that here in a second. So the reason why I think this was a manual operation to place these explosives, after the previous attacks, Russia constructed a lot of barriers around the bridge piers to prevent an attack by boat or submarine. I understand the water depth is only about 30 feet in this area. And as a reminder of the part of the world we're talking about, this is the only bridge linking Russia with the Crimea Peninsula. Show you the overall context within Europe. And this was a multi-billion-dollar bridge constructed, as I mentioned, from 2014 to 2018. And it's a real signature project for Russia. And here's a photo of some of the damage that occurred at the bridge deck right above the detonation at this bridge pier location. And of course, attacks on this bridge go back to 2023, where a rail car was loaded with explosives and detonated while on top of the bridge. This bridge supports one rail line and 4 lanes of vehicle traffic. Now, I've seen a number of schematics online that would indicate that these bridge piers are supported by pile foundations. In this article, I've got links in the description to all these references. It says the bridge is supported by over 7,000 piles of 3 different varieties. Board piles, reinforced concrete piles poured in the depressions on site, what we call drill shafts, where you excavate a hole, you place a reinforcing cage, and then you place concrete from the bottom up and then connect it to the cap. Prismatic piles, blunt wedge-shaped supports, and tubular steel piles. Those are typically filled with concrete after they're driven to their full depth. These piles were driven up to 300 feet below water level because of concerns about stability. And just another schematic that shows these piles supporting the bridge piers. Now I want to mention here from those schematics, the outside piles are what's called battered piles, and then other interior piles are vertical piles. Battered piles are installed to increase lateral stability. So you have wind loading, you have traffic loading that imparts a horizontal force to the bridge foundation, And so you can increase the resistance of the foundation to those loads by angling the pile from the vertical. Now, maybe some people expected this bridge to collapse outright. I'm sure Ukraine would have hoped for that, but I think there's likely to be significant damage to the pile foundation of this bridge if in fact it was a piled location. And the reason you can do a lot of damage and have the bridge still standing is that deep foundations, whether it's piling or drill shafts, are designed with a factor of safety. So let's just say, for argument's sake, that you've got a foundation that needs to withstand a load of, say, 5,000 kips, just to throw a number out there. And you would design the pile to have a geotechnical resistance of at least twice that, so 10,000 kips. And essentially a pile foundation where you've got a number of pile is a redundant foundation. You could destroy one of the piles, and if your cap is rigid enough, the loading that would have been distributed to the broken pile is redistributed to adjacent piling. And as long as you're within that envelope of the ultimate capacity or the geotechnical capacity, because of the higher factor of safety, you're not going to have a failure. As opposed to here on the right, we have a drilled shaft foundation, which is a type of non-redundant foundation element. So if you damaged the structural capacity of a drill shaft, there's no other adjacent foundation elements to take up that load. So you would no doubt have a collapse if you significantly compromise the structural capacity of a drill shaft foundation. Now, I would be willing to bet that the Russians sent divers out to inspect the condition of these foundations, at least from the cap down to the mud line, which is a very slow, tedious process. But from what I understand, you can see this bridge pier, and there's a gap from the bottom of the cap to the water. So you would think they could get access to do what's called sonic echo impulse response testing. It's a non-destructive testing which can be used to confirm the overall length of a pile, the condition of a pile or drilled shaft. You can determine if there's severe cracks between the testing location near the top of the pile and the mud line, or even deeper. And we just did this earlier this week, just a couple of days ago. There's an existing pile-supported pile cap that was built 30 years ago in anticipation of constructing a pedestrian bridge adjacent to a roadway bridge. And because the construction goes back over 30 years, the designer, doing his due diligence, wanted us to determine the length and condition of those pile and determine whether or not those pile extended to bedrock. We did other geophysical testing at the site to determine top of bedrock. And so this is the setup. We've got an exposed pile that we instrument with an accelerometer, and we have a hammer with a force transducer connected to a data acquisition system. This is what this system looks like. This is a data acquisition computer. We've got the instrumented hammer, accelerometer, and we have impact and receiver blocks that bolt to the side of the pile using concrete anchors. Now this just shows the mounting of the accelerometer. It's coupled to the receiver block with grease, and he'll impact the block to the right with the instrumented hammer. And that looks like this. So we're stacking the blows. We do 3 blows for each test. This is what it looks like on the computer. It's a bit hard to see, so I'll show you in the data acquisition program what this looks like. That's the force, the impact on the left, and the trace from the accelerometer on the right. So this is what it looks like in the analysis software. Again, you got the impact on the left from the force transducer, and you have the accelerometer trace, and we're able to pick out clearly where the toe of the pile is, in this case 15 feet from the location of our mounting blocks, which actually corresponded to the top of the limestone bedrock. So it was a very good test. But you could use this test to determine, again, is there damage before the intended depth to the toe? You can tell a lot with this type of test. And so I would think this Kerch Bridge could be further evaluated, its foundation anyway, using a test like this. So I hope you found that interesting. And like I said, we just did that test a few days ago. And I suspect that this bridge is severely compromised relative to its load carrying capacity. The Russians may have in fact reopened the bridge to traffic, but they may not be allowing heavily loaded trucks. They may not be allowing rail traffic at this point. just more details need to emerge on that. But they have a serious problem on their hands in terms of it just takes time to do a proper evaluation of how much loading that pier foundation can take given the damage from the explosion. So let me know what you think in the comments section. I want to point out I've got Buy Me a Coffee. I want to thank those of you who have contributed to that. That's a great way to support the channel. I'm avoiding channel sponsorships just because I think they're annoying. I'll never say never, but I'm trying to forestall the day if I ever have sponsors, and things like Buy Me a Coffee go a long way to making that a reality. I also want to thank the channel members. That's a great way to support what I'm doing here as well as those of you who have provided super thanks. So please stay tuned for future videos. If more information comes out on this bridge related to the foundation damage and implications for potential repair, I'll be sure to cover that. Thanks very much, everyone.